All right, good afternoon. I think I'm going to get started. I see there's still people coming in, but we'll start anyway since this is supposed to start at 2 o'clock. All right, I am Associate Professor Lim Tiong Wee, and what I'll do today is to share with you the Data Science and Analytics program at NUS, okay, details about what you can expect to do with this program, both in terms of what you study here and career prospects, and what some of our graduates have been doing. All right, I will try to keep this within my presentation within 30 minutes so that we leave ample time for questions. There is also a live chat session that starts at 3 p.m. Okay, so do feel free to join us again at 3 p.m. Where we will be happy to answer any more questions you might have. Okay, there are fundamental changes to the data science analytics program this year. So in case you have been doing your homework, in the past, and you have gone to our website to look at what the program is about in the past years, it will be different for this intake coming in AY 2021 and subsequently. So please do pay a little bit of attention here to what we have. The fundamentals of the program hasn't changed. The structure of the other requirements have changed slightly, okay, and for good reasons, and I will highlight them as we go along. All right, so this is the data science and analytics program. And of course, at the heart of it, everything is driven by data. All right, so I'll quickly show you some data trends, okay, and of course, these are things you can Google and find anyway, all right, but to just show you the magnitude of the amount of data we are generating from various activities that we engage in on a daily basis, that there has to be somebody around to make sense of these data and to generate insights on which we can act, okay, to improve things. So on a daily basis, now the human race is producing 2.5 exabytes of data. So this is 2.5 times 10 to the power of 18 bytes of data. This is a lot of data. And by some estimates, the human race will have created by now 40 zettabytes of data. This is 40 times 10 to the power of 21. So it's 4 followed by 22 zeros. So it's a lot of data. And of course, these are data that's created by our daily activities. It could be that we are, making purchases online. We could be, streaming content online, and more. There's also data collected and exchanged, okay, over the various networks by smart devices. Okay, so it is estimated by now there are some 50 billion smart connected devices in the world, and these devices collect, analyze, and share data. Okay, and what you might ask is this for? Okay, so all these smart connected devices constitute what is called the Internet of Things, and it is actually enabling things to be done in new ways, okay, and even new things to be done. So for example, the IoT is allowing for smart traffic management. This is something Singapore is moving towards. Environmental monitoring, predictive maintenance, and even logistic and fleet management, just to name a few. So for example, I will say a little bit more about predictive maintenance. If you have an equipment, okay, what will happen is that typically after some amount of use, okay, the machine may break down. And so what will happen is that the equipment needs to be maintained from time to time. Traditionally, the maintenance schedule is prescribed, which says that if you have been operating the equipment for a fixed amount of time, okay, or a prescribed amount of time, then you need to shut it down and send it for maintenance, okay? What might happen with this is that you are subjecting every piece of equipment, of the same type of equipment, to the same prescription, okay, in terms of maintenance. And due to variability in manufacturing processes, due to variability in how things are used, due to the variability in the environment in which the equipment is used, it could happen, and it often happens, that some equipment, okay, need not be maintained when they're due for maintenance. And there'll be some equipment that actually break down before maintenance is next due. So this leads to inefficiencies. So what the Internet of Things, all these smart connected devices, monitoring, and exchanging information with one another can do in such a situation is that it can actually give you much more information about the state of the equipment, okay? Whether or not, the equipment may be breaking down and what are the chances, and then recommend when one should shut down the equipment for maintenance just in time. So this allows maintenance to be carried out in a much more efficient manner, okay, where you only have to shut down the equipment for maintenance when it is necessary to do so. All right. And what can we do with all the data that we're generating to add value, so to speak? There are many applications, okay, some of which may be you may have heard. These are more popular terms. We have things such as high frequency trading, okay, in investments, risk management, okay, which is a big deal for many companies now. They have to put in place a rigorous framework for risk management, consumer intelligence, in which companies make use of data about you, okay, as the consumer, to try and sell you things that are relevant to you. And this is related in some sense to recommender systems as well, okay? For example, if you say we're streaming movies or streaming, shows on Netflix, or buying things online with online retailers, very often you will be recommended, with things that you could possibly watch or products you could possibly buy, okay? And at the back end, it is, an algorithm at work making use of data by yourself and people that you interact with, okay? There's also, data being used in medicine to personalize treatment given to patients, and that's genome-wide association studies. And then at the heart of this all, in Singapore, we have the Smart Nation Initiative, which is intending to use data to make our lives better, okay? Improve business productivity and so on. Okay, so let's quickly define data science for the purpose of, having some understanding of what this curriculum is going to be about. What are we trying to address? So data science is an interdisciplinary field. It's everything that's got to do with data. So we're talking about processes and systems, okay? And these are processes and systems that are used to extract knowledge or insights from data, and data can come in various forms, okay? So, what we put down here, extract knowledge or insights from data, this is fully general in the sense that you have to think about it. One has to collect data in this whole process, okay? And then store it somewhere, and then have the means to interact with the storage in order to extract whatever data that you are interested to look at, okay, to solve your problem. And then you analyze this data, and it is then you're able to extract insights from data, okay? And then you have to now communicate the insights or knowledge you have gained from the data to some other party, all right? So it is interdisciplinary because there are various things that need to be done, okay? Somebody needs to formulate how data collection should be done. Somebody needs to organize the data in a certain way, okay? Into a database, for example. Somebody needs to query the database for the data itself, and then somebody needs to do the analysis, and so on. So for that reason, one will have to make use of techniques and theories drawn from various disciplines, including computer science, mathematics, and statistics. So in a nutshell, what a data scientist would do is to apply analytical tools and techniques to structured and unstructured data to solve complex problems and derive actionable insights. So this is in a nutshell what a data scientist needs to be equipped with, okay, and for what purpose. They need to be equipped with analytical tools and techniques, okay, and these are tools and techniques that can be used on data, both structured and unstructured, and it's for the purpose of solving complex problems, okay, with a mission in mind, which is to derive actionable insights. These insights need to be such that you can make use of them to improve things, improve processes, okay, improve productivity, improve profits, and so on. Okay, in some more concrete terms, okay, let's look at what some of our alumni have been doing as data scientists. Okay, the Data Science and Analytics program came about in 2016. So before that, the Faculty of Science, okay, now offering programs under the umbrella of the College of Humanities and Sciences, have been offering the mathematics, applied mathematics, and statistics programs for a long time. Okay, and so we have ample data from graduates of these programs that predates DSA. Okay, and many of them have actually gone on to become data scientists themselves. Okay, and it's on that basis that we are actually building, that we have built the DSA program and improved it, okay, under the umbrella of offerings now under the College of Humanities and Sciences. So this gentleman here is Dr. Eric Sandosham. Okay, he graduated in '95 with an honors degree in mathematics, and then he came back to school and did his master's in statistics, graduating in 2002. Okay, he has since gone on to found his own consulting firm, the Red and White Consulting Partners, and this is what he describes what he does. I provide data-driven solutions for clients across Asia Pacific in diverse industries. I blend the art and science of analytics to connect the dots between people, products, and profits. Okay, so what he describes his work as a data scientist is that he provides data-driven solutions. Okay, to clients in diverse industries. So the applicability of data science and analytics is diverse. Okay, it's not limited to just one sector or one industry. It is diverse. Okay, and as a consultant, as somebody in a consulting firm, Eric gets to work with many different clients in many different industries and sectors. Okay. But if you want something more concrete in terms of what one would do in sectors, here's an example. In the healthcare sector, Ivan John Clement, okay, who graduated in 2013 with an honors degree in computational biology. This is again why he describes what he does at work. I utilize advanced analytics and machine learning to analyze healthcare data sets, which transform our understanding of healthcare outcomes. This enables us to deliver the right drugs to patients at the right price. So what does he do? He looks at healthcare data. He applies analytics and machine learning. Okay, there's an understanding then of healthcare outcomes, but the actionable part of it is that then the company is able to sell patients the correct drugs at the correct prices. Okay. So this is, so the insights are actionable, and action can be carried out on the insights themselves, which will a better understanding of healthcare outcomes. And then we have Mr. Tie Yu Xuan, okay, who was a top student when he graduated from statistics with honors in 2014. Okay, this is what he describes, what he does when he was a data scientist in Lazada Group. Okay, that was a few years back. He is now a senior data scientist with Ninja Van. So what Yuxian says is that he develops machine learning models that analyze large-scale data for consumer behavioral patterns to make personalized product recommendations. This enhances the customer experience and promotes sales. So again, it's the same sequence of things. He looks at data, large-scale data. These are consumer data. He analyzes them, and what does he try to look for when he does the analysis? He tries to look for consumer behavioral patterns. And then, so this is the insight, consumer behavioral patterns. But how does one act on this? One acts on this then to make personalized product recommendations. And the outcome would be that customer experience is enhanced, customers are happy, and they buy more, basically. So, the bottom line to the company is that sales are improved. All right, and the outcome to the customer is that they are happier, shopping back then with Lazada. Okay, so these are some aspects of what one can do with data science and analytics. So we have this data science and analytics undergraduate program at NUS. It was launched in 2016 as a direct admissions program. Okay, starting this intake in AY 2021, okay, under the College of Humanities and Sciences. It is no longer direct admissions, okay? It's important to pay attention here. The program now is not anymore a direct admissions program. It is now a major program within the offerings of the College of Humanities and Sciences. That means when you apply, or if you are interested in pursuing a BSc degree program with a major in data science and analytics, you will have to apply to the humanities and sciences course in the admissions portal. Okay, and if you're successful, you'll be admitted to the humanities and sciences course when you matriculate. Okay, then you declare your major as data science and analytics. All right, so that's critically different this year. So that's something to pay attention to. No longer direct admissions. Apply to humanities and sciences course under NUS. Okay, when you go to the admissions portal, hopefully, okay, and I hope you do get admitted. Okay, and when you matriculate, you declare your major as data science and analytics. Okay, so that's something that has changed in terms of the admission or application procedure. But what hasn't changed, of course, is that the program continues to be jointly offered by two departments here, Department of Statistics and Probability, that's my department, and our partner department, Mathematics, in the Faculty of Science, and everything falls under the College of Humanities and Sciences now. And we have collaboration, from School of Computing, because they offer, a number of CS courses within the curriculum. Starting this year also, due to the revision of the curriculum, students in the data science analytics program have the option to specialize. Okay, we'll be introducing two specializations, one in operations research and one in statistical methodology. All right. The specializations, are pending approval from the university, but we don't expect surprises here. All right. So that's something different this year. Starting with the intake AY 2021 this August, students in the data science and analytics program have the option to specialize either in operations research or statistical methodology or both. Okay, so what is this program about? What will it do for you? It will equip you with analytical tools and techniques that will enable you to solve complex problems, okay, anchored on data in various sectors and domains. So this echoes back to what Dr. Eric Sandosham was describing. Okay, the sectors and domains are diverse, okay, but what you have to do then is use data along with tools that are relevant to these data to solve problems in these sectors and domains. And in addition to these as well, you will also be equipped with skills to communicate the insights you gain, possibly using visualization tools, okay? And in 2016, we were the first university in Singapore to offer a degree program in data science analytics. Okay, we have just had one cohort of students graduate last June, okay, in difficult circumstances, but they have done well, okay? So they have enjoyed a competitive edge in the job market. Okay, how did we define the curriculum, and what were some of the thought that has gone into the design of the curriculum? The curriculum, is designed with two things, and we have to balance these two things. We have technical depth, particularly in relation to specializations. Okay, there is also a breadth of domain-specific knowledge. So what does that mean, or what do I mean by domain-specific knowledge? The techniques that one picks up in this program can be applied to various sectors and domains. So it is important, okay, within the curriculum to have opportunities for students to apply, okay, or learn to apply the knowledge they have learned into various domains and understand what are some of the relevant problems that could be encountered in various domains and sectors. Technical depth is of course, acquired within the program itself. And why did we insist on technical depth? And we have seen this very clearly, perhaps in the past year or so, under the COVID-19 regime, many things have changed, okay? But the one thing that, will not change is the fact that if you have technical knowledge, if you have deep technical knowledge, you are able to reinvent, okay? And, come back again stronger. So technical depth ensures that our graduates are able to develop novel tools for applications on problems that will emerge in future. So it future readies you against emerging needs that we can't anticipate just yet. All right, so we emphasize the need for technical depth, and we built enough of it into the program, along with a range of applications to different domains and sectors. Okay, so that students see how the techniques that they have picked up, the knowledge that they have picked up, can be applied in various domains and sectors, and able to do so confidently. And the way to instill domain-specific knowledge is by working with industry. So we have put in place several industry-linked modules and projects, okay, including, of course, internships, so that students have ample opportunity to actually, try out different domains and sectors, okay, if they are, somewhat, on the fence, they haven't decided on which domain or sector they want to enter, or if you already know which sector or domain you are interested to build a career in as a data scientist, then you may also, attempt to do internships or take modules that address the needs of these domains or sectors. Okay, so the program envisions to instill or equip our students with both hard skills and soft skills. Hard skills are learned in the university, okay? You will be equipped with subject matter expertise in data science, okay, together with its constituents, computer science, statistics, and mathematics, okay, hence here math, stat knowledge, data and technical skills, okay? So these are things you pick up in school. And then you can work on industry-linked modules and projects, take up internships, and this will allow you to sharpen your soft skills. And this involves such things as communication. You have to work with people, collaborate with them, okay? And then if you work with the right people under their, guidance and mentorship, you're able to, learn how to formulate and solve problems, and then how to present your findings in a way that's interesting and understandable to non-experts, so to speak, non-data experts. It could be management, okay, it could be the general public. So soft skills are picked up mainly through experience, okay, in industry-linked modules or in internships. So let me briefly go through the program structure that will come into effect this August under the College of Humanities and Sciences. All right, there is a CHS common curriculum. CHS stands for College of Humanities and Sciences. And this will include such things as AI, artificial intelligence, CT, computational thinking, community engagement, DT, design thinking, QR, quantitative reasoning, W, writing. Okay, these are general education modules. In particular, the quantitative reasoning requirement will be fulfilled, okay, by students in the DSA program by the gateway module, Introduction to Data Science. So you can see in this instance here, the common curriculum space is 52 MCs, but because of the fact that the QR requirement can be fulfilled from within the major itself, the effective requirement for the common curriculum in the case of a DSA student is 48 MCs. Okay, then there are also exposure or modules to various aspects of humanities and sciences. So we have Asian studies, humanities, social sciences, scientific inquiry 1 and scientific inquiry 2. Okay, in addition, interdisciplinary modules 1 and 2, there are 2 of them. Students select from a basket, which will be made known to you in due course. And this constitutes a basket of 13 modules in the common curriculum, one of which is fulfilled by a DSA core module. So for a DSA major student, the effective number of modular credits for the CHS common curriculum is 48. The major constitutes 60 MCs of requirements, of which 52 are essential, 8 are elective. Okay, what has changed this year, okay, or with this coming intake, is the fact that we now offer specializations within the DSA major. Data science and analytics students can choose to specialize either in operations research or statistical methodology or both. Okay, each specialization constitutes 20 modular credits. Students can also use the unrestricted elective space to participate in internships or read minors or read the second major. Okay, it has to be emphasized that the specialization, beginning with this revised curriculum for the CHS, specializations are now outside, over and above, okay, the basic major requirements. So the basic major requirements is 60 modular credits. Okay, students can choose to specialize. Each specialization would add an additional 20 modular credits, which they would have to use from that unrestricted elective space. Okay, the total modular credit for the entire program is 160 modular credits. This is common throughout the whole university for a 4-year direct honors program. 48 effective MCs from the common curriculum, 60 MCs from the major requirements. The balance of 52 MCs will be from the unrestricted elective space. Okay, when do students choose specialization? It's a good question. We will tell you that when you matriculate in August. Okay, but the procedures have been currently being worked out. Okay, quite likely specializations can be chosen at the beginning when you matriculate. All right, so what's in the major? I mean, this is not a forum to list for you all the modules that will be read. Okay, but just to give you a flavor of what you can expect, there'll be foundations in the 3 constituent disciplines of data science. There's computer science, there's mathematics, there's statistics. Students will be equipped with such things as programming, data structures, and algorithms. And then in mathematics, one learns about linear algebra and calculus. In statistics, probability and inferential statistics. All right, there's also the aspect of data analytics. Okay, the essentials include such things as visualization, computation, and optimization. There's also core techniques in data analytics, such as regression analysis and machine learning. Okay, then there is data science. The students would take a gateway module which introduces them to data science, data acquisition. They get to see what happens in the data science pipeline. Okay, and then the guest lecturers would come in and share what they do at the workplace, just to get students excited, and look forward to what else is to come in the curriculum. There is also a data science and practice module which students read in the 3rd year. Okay, which further introduce them to such things as ethics. Okay, possibly such things as interaction with databases, and then there will be projects and electives to complete the rest of the data science education. Okay, for our major students. All right, there's a question about programming languages used in data science. The programming methodology module, okay, which students would take under the computational thinking requirements in the common curriculum, what is called CS 1010S in NUS, that uses Python. The visualization module, okay, and many of the statistics modules that one would take would use R. Okay, so students would be equipped with both Python and R, which are 2 of the most commonly used programming languages by data scientists at the moment. Okay, and then there's also ample opportunity, like I said earlier, to enhance your soft skills, ample opportunities for experiential learning. Okay, there's of course opportunities for internships. The College of Humanities and Sciences have opportunities for students to participate in internships and earn credits under the Undergraduate Professional Internship Program. Okay, students can take on full-time internships during the semester or during the special term, and they will earn credit for it under UPIP. And if you enter in August, okay, then hopefully in 2 to 3 years time, travel will be resumed, okay, and then you could go on overseas student exchange, okay. Students who have done this have found that it is very valuable in terms of personal growth and development, okay, when they have to go somewhere else and sort of manage themselves on their own. And also it's good to learn about another culture, all right, and have a sort of more global view about, you know, from this experience. Okay, there was a question here, maybe I'll just quickly answer that, about whether or not one needs to have some computing from high school, and the answer is no. The programming methodology module doesn't assume that, okay, and so programming is taught from scratch, so to speak, and doesn't require any prior knowledge or experience with computing. Okay, what I want to focus on within the data science curriculum are these three things in red and larger fonts: cooperative education, okay, internship on steroid, data analytics consulting projects, okay, which is an initiative. We have a data analytics consulting center, and you know, there are projects there on which students can work on, okay, and students can get paid for doing so, and then they in some sense get some experience acting as consultants. And we have a full suite of data science sense-making modules, okay, that allows students to work on projects in a hackathon style, okay. So you know, there's a scenario, there's data, students formulate questions, and then they try to answer these questions using data, okay, to find insights that's relevant to the business needs of our partners. Okay, so I will talk about these three things in some more detail over the next few minutes. Cooperative education. Okay, this is a program or pathway that's available to DSA students in which they combine academic studies with on-the-job learning. And what is done is that there is a study work sequence, okay, that is prescribed, and it is on this sequence in which students complete their studies and work at the same time, basically. And we have had this cooperative education pathway available to data science and analytics students since 2017. But due to the fact that, you know, we are revising the curriculum for CHS right now, the sequencing has to be revised as well. All right, so what we anticipate will happen is that students will now spend 16 months in the workplace. Okay, this is where they pick up skills and knowledge, as well as expertise that are needed to secure themselves rewarding positions with outstanding employers after graduation. So there is some revision. Details will be ironed out by the time you matriculate in August. So this is the current state of things. It is anticipated that the 16 months of internship under the co-op pathway will take place from semester 2 of the 3rd year of study, and this will be completed, okay, in semester 2 in year 4 of your study, when you are due to graduate at the end of the semester. So full details will be available when you matriculate in August. Okay, so these are some of our co-op partners. On the left, you see the current co-op partners, in the sense that they are proposing cooperative education internships, okay, for our students. These are past ones on the right, okay. There's some 20 partners in the DSA co-op. Of course, not every one of these partners would have positions available in every cycle, okay, but you can see in this instance here that there are many diverse industries, okay, and that's the key point over here. Okay, so internships. I did mention about internships, and because the curriculum is undergoing some changes, starting from AY 2021, the pathways available for internships will also be revised somewhat, but nevertheless, as a reference, these are some of the companies or organizations with which our students have participated in internships with in the past 2 or 3 years. Okay, and again, it's not intended to show you or to dictate to you where you should be looking for internships, but it's really to give you a sense of the diverse nature in the industries and sectors where you can find data science work basically. For example, you have Carousel online retail. You have Johnson & Johnson, fast-moving consumer goods. You have things like Micron Semiconductor. You have SWAT Mobility, which is a local startup dealing with on-demand transport services. One of the things that they look at. Okay, if you've been reading the news maybe a couple of years ago when there was a trial going on in the Marina area and the Tuas area when there's on-demand, transports. One can, there's an app, V-Line, like if I remember correctly, where you can, hail a bus, so to speak. Okay, I think SWAT Mobility was one of the partners over there implementing the trial. Okay, and then you have Yara that does agriculture. Okay, which is going to be a big thing in Singapore because Singapore is trying to grow 30% of the things that we consume. So agriculture is going to be a big area in the next 10 years or so. So you can appreciate the diversity in where one can apply data science. Okay, and I'm quite certain there's going to be some area that will interest you. Okay, both at a personal level and at a professional level. Consulting projects, which I'll talk about quickly with Data Analytics Consulting Center. We provide consulting service, okay, and we get students involved, okay, in these consulting projects. They are to provide data-driven solutions, and then they get experience in solving real-world business problems. And then we have the data science sense-making modules. These these modules are offered regularly on a semester to semester, but the sectors and domains change from semester to semester. We have 6 pairs of sectors, okay, such things as health and medicine, logistics and transports, business and commerce, economics and finance, public policy and society, science and technology. So it covers essentially everything under the sun. So this is an example that of a project that students worked on a year ago. Okay, this is a maritime themed project. Okay, it's hackathon style. So students were given 10 billion lines of AIS data. So this is shipping data. The ships will ping every 10 minutes, if I remember correctly. Okay, their location to a database, and then the ship crew will actually input what they were doing, okay, during at the time when the data is being pinged, okay, to the database. So based on such data, the students were tasked with determining or finding shipping patterns, to determine whether or not there was illegal fuel bunkering. Fuel bunkering is where a ship takes on fuel, okay, and so the bunkering vessels needs to go in and provide fuel to the ship itself. And because it's a multi-trillion-dollar business, that fraud is not uncommon, and so there's a big business here in attempting to determine whether or not there's fraudulent behavior on the part of the bunkering vessel as well as the ship that takes on the fuel. So students worked on this, and then they proposed various different interesting solutions and approaches. And so like I said earlier, this is done hackathon style. So at the end of the day, each group of students will present what they did and why they did things, and then what they found and how this will help improve the detection of illegal fuel bunkering activities. Okay, career prospects. our graduates can expect to build a career as data science professionals in both public and private firms, diverse industries, e-commerce, finance, healthcare, infocom, marketing, manufacturing, telecom, transportation. Okay, everywhere there is extensive data collection, the data needs to be processed, analyzed, okay, and then actionable insights need to be generated. So our graduates can expect to build fulfilling careers in any of the sectors that they find interesting. So just to share with you, we have just one cohort of students gone out, a small cohort of some 25 of them. Okay, and this is a sample of employers. These are actual employers. These are not hypothetical ones that you find on LinkedIn or some other job portal by Googling or by searching for data science or data scientists. These are actual organization that has hired our students in the last challenging year, okay, due to COVID-19. So you can see again, it's a diverse mix of companies from different industries. Okay, the exact name of the companies don't matter. Again, I want to instill in you the fact that there are many possibilities. Okay, and why is this so? The reason being that there is still a substantial shortfall worldwide in individuals with expertise in data science and analytics. Okay, the IMDA sort of conducts a survey on an annual basis called the Infocom Media Manpower Survey. Okay, the last one being done in 2019, and or the last one that was with results being released is from 2019, and the survey would show two things: current status, who's employed in what, how many of them, and then how many more are needed, basically. So because it's the 2019 results, the cutoff date was June 2018. Okay, the survey showed that 16,400 professionals were employed in what they call critical emerging tech specialist roles. Okay, and that includes data science or data scientists, and 1,800 roles remain vacant. So there's a shortfall. Okay, and when enterprises were asked to project the demand, they projected that they needed another 9,300 headcounts into emerging tech specialist roles in the next 3 years from 2018. So that will cover, the expected demand until the end of this year. So, so people with expertise in data analytics are in, good demand, okay, and one can expect to be able to be gainfully employed in something meaningful after one graduates if you major in data science and analytics. All right, so that's all I have. All right, I thank you for your attention, and I will begin to answer some of the questions that have come across on chat. All right, so let's take a quick look. And in case I couldn't finish these questions, we'll then roll them over to the live chat. We'll talk about them. Okay, admission pre-requirement, that information will be available on the admissions portal. Okay, I believe it's quite general, and in particular, to declare a major in data science and analytics after matriculation, one needs to have a very good H2 pass in mathematics or equivalent. So that's the admission requirement, so to speak, into the data science and analytics major. Okay, I think there are questions about how one can get into the data science and analytics program. It's a two-stage thing. All right, well, I'm going to say this again, it's very important, two-stage. First, you have to apply to a course, okay, in the NUS admissions portal. The course is humanities and sciences. Okay, apply to that course if you want to do data science and analytics, humanities and sciences. Okay, after one has applied and gain successful admission to the humanities and sciences course, then upon matriculation, you choose your major. So if you intend to do data science analytics, that's when you choose the major, data science and analytics. Okay, and what is needed to choose data science and analytics? You will need H2 pass or equivalent, a very good H2 pass or equivalent in mathematics. All right. And if you don't have that, then you have to take a bridging module, what we call MA 1301, that will bridge you to a proficiency equivalent to H2 mathematics. Scholarships, there's of course the NUS scholarships, okay, and we are finding that there are more and more scholarships targeted at data science students. We have GovTech scholarships, or I was made aware that there are also GovTech scholarships as well. Of course, these are not administered by NUS, okay, but there are many organizations that are providing scholarships to students in data science programs. Okay, there is a question about the quota of student intake for the DSA major in CHS. No, there's no quota. Okay, we'll take as many qualified students as there are who have gained admission to the humanities and sciences course who want to do data science and analytics. So there's no predetermined quota for the major. Okay, so it is essentially guaranteed. Okay, if you have managed to gain admission, okay, to the humanities and sciences course offered by the CHS, okay, if you fulfill the major prerequisites, a very good H2 pass in mathematics or equivalent, okay, including if you don't have that, the bridging module MA 1301, then you will be able to declare the major in CHS. There will not be any other hurdle you need to cross. Yes, a major in data science is definitely compatible, okay, with a minor in computer science, and that can be attempted. We have many students doing that, okay, so it's quite a popular combination, a major in DSA with a minor in computer science. Difference between DSA and business analytics, I'll be very brief on this. There's only this much curriculum space, so the emphasis or what you put inside the curriculum, some has, if you emphasize some, then you will have to give up the space for something else. Okay, like I mentioned earlier, a key feature of the DSA curriculum is technical depth. Okay, so there is substantial rigor in how one approaches data analysis. Okay, and you can see in this instance here, you have such things as inferential statistics. Okay, which gives you the overarching principle for general data analysis, and that's important. Okay, because this is what will ensure that you are able to develop novel tools for data that you have not even seen right now, basically. So emerging needs. So that's a key difference. Okay, there's a question relating to the cross-disciplinary program on data science and economics. Okay, to put it quite simply, if one does data science and analytics, DSA, you can apply what you learn to any domain, so to speak. Okay, provided of course you make a conscious effort by taking modules, by doing internships in related domains. Okay, so that you know what are the emerging needs in those domains, and then you speak their lingo or language. Okay, if one were to apply to the XDP in DSE and is successful in gaining admission to that program, then to some extent, you have already committed yourself to a domain or sector, that being economics. Okay, of course, the program is great. I'm also directing that program, so I made a talk earlier, and that program is great. Okay, but you have already committed yourself to a sector. Okay, the curriculum was designed specifically for that purpose, and so it is much harder than to try to move out of that sector. Okay, so that is how one should think about DSA versus the XDP in DSE. Okay, there's a question comparing our program to some other university's program, whom I shall not name. The way to think about this is the following. I did have a slide talking about that this year, okay? It is, after all, a program that has three components to it: mathematics, statistics, and computer science. Okay, if you think about it, you want to learn from the best. And an indication or indicator of who's the best, okay, at least a proxy of it, is research ranking, basically. Okay, and mathematics, specifically operations research, statistics, and computer science at NUS are ranked in the top 10 or so, okay, in the world. And what that means is that you're learning from the best. You have the opportunity to do projects with, you know, some of the best researchers in the world, and I would think that's an advantage, okay, in coming to the NUS program. Okay, let me see. There is a question about taking computer science modules. Yes, particularly the question addresses natural language processing. Yes, there's a computer vision. Yes, subject, of course, to the module quota set by the School of Computing. Okay, but other than that, these modules are open to other students. You may be aware that there's a registration system in NUS for modules, and this is based on some scoring system, and students from outside the School of Computing doing their majors are able to read modules offered by the School of Computing, but then the scoring system would have some way of coming up with a score, and then they will prioritize different types of students for those modules should the module be oversubscribed. Okay, at the moment, there's no certification for data scientists. We don't know how things will be locally or globally moving forward. Okay, as I mentioned earlier, the term data science is very broad. Okay, you could be talking about, and also in relation to that, for example, if you were to go on job portals or go on LinkedIn and you attempt to search for data science, some of the companies that have been talking about data science for a while have differentiated roles now. Okay, it could be that within the data science role, they're looking for somebody who's able to design and manage databases. Okay, so that would be a data engineer. Okay, and then you could have people who the ones who are actually doing the number crunching, and these are the data analysts. So it's a broad term. There are many different things that can be done with data. So certification come later, but I frankly do not know, or am not aware of what might be in the works for this kind of certification at this point in time. I've already answered business analytics versus DSA. Size of intake, we don't know. Okay, quite frankly, if the entire CHS intake chooses to declare DSA as a major, hypothetically, okay, then we will take all of it. Because that's by design, okay, how things are done. Okay, you get admitted to the humanities and sciences course, and then you're free, subject to major prerequisites, you're free to declare your major. Okay, so in principle, at one extreme, the whole college may do DSA, okay, although God forbid it doesn't happen. At the other extreme, none will do DSA, and again, God forbid that doesn't happen. All right, so we think there's going to be a good size intake, but there is no quota, like I said earlier. Okay, there's a question about starting salaries and employability. I wouldn't go through the numbers because it may sound a little bit braggy, but please refer to the Graduate Employment Survey 2020. Okay, that was released, I think, just in the past week. So if you Google Graduate Employment Survey 2020, that will give you an indication of the median and the 75th percentile of starting salaries, okay, of graduates from 2020, okay, and percentage of students who found full-time employment. C language and Java are not currently in the program, but my understanding is CS 2030 uses C and Java, or C++ and Java, if my understanding is still correct. So one can always read the module to learn about C++ and Java. Okay, I think there's a misnomer about, the different types or different roles or different levels of expertise of data scientists. Okay, as I've shown you, I think, you shouldn't graduated in 2014 with a bachelor's with honors, very good honors. He's a top student in our cohort. Okay, and he got his job. He got a job as a data scientist immediately, and has since moved on, I think, 4 or 5 different companies. The demand is there, basically. So yes, of course, they hire PhDs. These are people to lead an entire data science team. Okay, but there's certainly roles available for honors students. Of course, you have to do very well. So you have to work hard and make sure that you do well, both in terms of grades and in terms of picking up the right experiences while you are here. Other than that, I don't see why a good honors degree will not be sufficient for one to become a data scientist. Okay, I think some of the questions are already duplicated, and I think we are running out of time, and there's a specific question about what grade is enough. Unfortunately, I can't answer that question. You have to gain admission to humanities and sciences. There will be a cutoff for all humanities and sciences majors, okay? That cutoff applies to everybody entering the humanities and sciences course, and then you declare your major. It's a question about double degrees. We don't have upfront double degree between DSA and CS, okay? But it's certainly a possible combination. You can't do a double degree between DSA and math, both are science degrees. That wouldn't work. the degree you receive for the DSA major is Bachelor of Science with honors. Okay, it's a new program. We have no IGP, so I can't comment on, what would be a possible cutoff here. Okay, there was a question about where they can go to view this. You can review it. Okay, Ms. Tong has already answered that question. You can review this session on Facebook, our department's Facebook page, DSAP's Facebook page. Okay, I think we're going to move on now to the live chat session. So I'm going to close this session, and then we can answer some of your questions again. And we can, or you want to talk more informally, we'll be happy to chat with you in the live chat session. So thank you very much. Okay, we'll end it here.